Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Zaki bin Cik Saleh. Today I will solve the question for number 1, which is f fx equals to x power 4 plus 2x cubed minus 3x squared minus 4x plus 4. So for the question A, they ask for critical number. So A, the critical numbers of fx. So if you want to find the critical number, we need to use f prime x. We know f prime x equal to 0, or f prime x equal to 0, or f prime x is undefined. So for the question A, when f prime x equal to 0, so we know the polynomial is defined for any numbers. So we use f prime x equal to 0. So we differentiate the equation, we get 4x cubed plus 6x squared minus 6x minus 4 and equal to 0. So now we need to simplify the equation. So we divide by 2. We get 2x cubed plus 3x squared minus 3x minus 2 equal to 0. So now we need to do some of coefficient. And notice that x equals to 1 is a root. Okay. To prove the x equal to 1 is a root, we need to insert the x equal to 1 to the equation. So 2, 3 plus 3, 1, 2 minus 3, 1 minus 2 equal to 0. So we get the answer is 0. So x equal to 1 is a proof that is a root for the equation. So next, the first derivative, which is f prime x equals to 2x cubed plus 3x squared minus 3x minus 2 and 2x cubed plus 3x squared minus 3x minus 2 equal to 0. We need to divide by x minus 1. Because x minus 1, how we get the x minus 1 is from x equal to 1, which is the root is a root for this equation that we proved before this. Okay, so we get the answer is 2x squared plus 5x plus 2 equal to 0. So we do some factorization for this equation. We get 2x plus 1 and x plus 2 equal to 0. So the value of x, we get 1 over 2 and s equals to negative 2. So the critical point is s is equal to 1, s equal to negative 1 over 2, and s equal to negative 2. So we get the critical point. Alright, so we continue for question B. Question B, they ask for the point of which fx has a relative extremum. Relative extremum, which is relative maximum or relative minimum. So first of all, we need to find the interval. So the interval, which is negative infinity to negative 2, negative 2 to negative 1 over 2, negative 1 over 2 to 1, and 1 to infinity. So we need to do a test value, which is we need take the value between negative infinity to negative 2, which is negative 4. So we insert the negative 4 to first derivative, we get negative 140. For negative 2 to negative over 2, we get 4, and so on, negative 4 and 14. So by this table, we can see that we as if as x equals to negative 2 is a relative minimum. When x equals to negative 1 over 2 is relative maximum. And lastly, when x is equals to 1, it's relative minimum. So to get the point of extremum, we need to insert the value of x to origin equation. So the origin equation is fx equals to x power 4 plus 2x cubed minus 3x2 minus 4x plus 4. So we insert the value of x, which is negative 2, f negative 2, so negative 2 power 4 plus 2 negative 2 cube plus minus 3 negative 2, 2, negative 4 negative 2 plus 4. So the answer will be 0. And for when x equals to negative 1 over 2, we get the answer is f negative 1 over 2 equals to negative 1 over 2 power 4 plus 2 negative 1 over 2 cube minus 3 negative 1 over 2 square minus 4 negative 1 over 2 plus 4. The answer is 81 over 16. And then lastly, when x is equal to 1, f1 equals to 1 power 4 plus 2, 1 cube minus 3, 1 square minus 4, 1 plus 4. We get the answer is 0. So, the point of fx has a relative maximum, which is the point of relative relative extremum, which is negative 2, 0, negative 1 over 2, 81 over 16, and 1, 0. So this is the point of relative extremum. So for the question C and D will be continued by my friends Chizahiro. Thank you.
So in question C, the interval on which fx is increasing or decreasing. So as we already go through question A, the critical number is x, negative 2, 1, and negative 1 over 2. So the first step that we have to use to determine which interval is increasing or decreasing is we have to write the interval for each critical number. So the first critical number is negative infinity, sorry, -2. The second interval is -2 to -1/2, -1/2 to 1, and 1 to positive infinity. So the equation that we have to substitute is not the original question, but the original equation that we have derivative, which is the first derivative. The first derivative that we got is 4x cubed plus 6x squared and 6x minus 4. So this is the equation that we are going to substitute the value to determine which interval is increasing or decreasing. So we are going to test. So the first interval, the value that we are going to take is within the range in the interval. For example, in this interval, -infinity to -2. So the value that we are going to take is like -3, -4, and -5, -6, and so on. We cannot take -1 because it exceeds the range that are given. So for the first interval, I'm going to test with -4 first, -4, and we are going to substitute with the equation, first derivative equation. So 4 cubed plus 6x, 6 -4 square minus 6 -4. So if we take it to the calculator, we got -140. So we can see that the symbol is negative, so it is decreasing. For the second interval, like I just said before, we have to take the value that are within the range that are given. So in this interval, we can take -1. So I'm going to take -1, and if we substitute, we will get that -1 equals to 4. You have to take the -1 and use the equation from the first derivative, and we get the answer is 4. So this is positive, so it is increasing. So the third, we can use the value that we are going to take is 0. So if we use the calculator, we got -4, which is the interval is decreasing. And for the last interval, we can take 2 or 3 or 4 or 5, but I'm going to take 2. So if you substitute with the equation, the first derivative equation, we got that 40, which is positive increasing. So we can see that our graph is going to be decreasing first, increasing, decreasing again, and increasing again. In question D, we have to plot the graph using GeoGebra. So for our, as we know before, the critical number is 2, 1, and -1/2. This is the critical number. So basically, critical number is either it is the maximum or minimum point in the graph. for the critical number, we only get the x-axis. So in order to get the y-axis, we have to substitute the critical number value in the original question. In the original equation. So our original equation is x plus 2x cubed minus 3x squared minus 4x plus 4. So we have to take the critical number and substitute in the original equation to get the y-axis. So for the first critical number is 2. We are going to substitute all with 2, all the x with 2. Plus 4. If you take the calculator, all we get is 0. So for the first the minimum point is 2, 0. So this is our first point if we got to plot the graph. So for the second is 1, 1 cube 1 square 1 plus 4. If we go to the calculator, we can get the value is 0 2. So for the second, our maximum point, it is 1 0. This is our maximum point in our graph. So for the last critical number, we get that -1/2. So we are going to substitute with our equation. We get that the value is not 0 but 81/16. So for our last minimum point is -1/2 and 81/16. So this 3 is our point that we have to plot in the graph. So if we go to the GeoGebra, fill back the equation with our original equation, and the graph will be like this. And the point that we calculated before, for the first is -2 0, which is minimum point, and for the second we got the -1/2 and 81/16. So this is our maximum point, and for the last, our minimum point is 1 0.
Hi, Assalamualaikum. My name is Narafina Shafika, and this is the second question of our calculus assignment. So the question is, two parallel sides of a rectangle are being lengthened at the rate of 2 inches per second, while the other two sides are shortened in such a way that the figure remains a rectangle with a constant area, 50 inch square. So our question is, what is the rate of change of the perimeter P when the length of the increasing side is A 5 inch, B 10 inch, and the last question is, what are the dimensions when the perimeter ceases to decrease? Okay, so what we need to find is dP over dt, and the information that had been given to us is dx over dt, which is rate of to inch per second. Also the area. So we know that the formula for the area is xy is equal to 50 inch square. So this is the information that we have, 50 inch square x over dt. So we need to find dp over dt. So from the formula of the area, xy is equal to 50 inch square. So we bring the x to the other side, and we will get y is equal to 50 over x. So we let u is equal to 50 and v is equal to x. What we need to find is dy over dt. So we need to use quotient rule. This is the formula for the quotient rule. vu prime minus uv prime over v square. Okay, so we insert all of the information. So we need to find the du first. So we integrate u, we differentiate u, we got 0 dt, and if we integrate v, we will get dx over dt. So all of this information we need to substitute in our quotient rule to get dy over dt. After that, we know that dx over dt is equal to 2 inch square because the question has been given to us. So we solve it and we will get negative 100 over x square. So for the question, so next we want to find the perimeter, right? So the formula for the perimeter is x plus y plus y. So I simplify it. So it will be 2x plus y. Next, we differentiate again to get dp over dt, and we get 2 dx over dt plus dy over dt. So we just need to substitute the value, and we will find when x is equal to 5 for the first question. So when x is equal to 5, our dp over dt is equal to negative 4 inch per second. And for the question B is when x is equal to 10. So we substitute 10 in our x and we will get 2 inch per second. So for the last question, what a dimension when the perimeter causes to decrease? That means our dp over dt is equal to 0. So when we do dp over dt is equal to 0, we just need to bring 2 to the other side and we will get negative 2. So negative 100 over x square is equal to negative 2, and we will get x is equal to square root of 50, and the final answer is 5 square root of 2. So that's all for the question number 2.
Hi everyone, so today I will explain question 3. Question 3 states that the total cost of producing X radio sets per day is Rm 1 over x squared plus 35x plus 25, and the price per set at which they may be sold is Rm 50 minus 1 over 2x. So question A states that what should be the daily output to obtain a maximum total profit, and question B states that show that the cost of producing a set is a relative minimum at their output. So first we need to state each equations. So the total cost is Cx equals to 1 over 4 x squared plus 35x plus 25, and then the price per set which is 50 minus 1 over 2x, and the revenue total which is sets times the price, which is we put the sets as x and px, so x times px equals to 50x minus 1 over 2x squared. So what are we finding? For question A, we are finding the daily output x that gives maximum total profit, and question B, the cost per set is a relative minimum at the output. So the first step, we write the profit function capital Px. So profit equals to revenue minus cost. Px equals to Rx minus Cx, so we just fill in and then we will get negative 3 over 4x squared plus 15x minus 25. Step 2. Find the critical points for profit. To find the critical points, we need to use the first derivative. So differentiate Px with respect to x, and we will get negative 3 over 2x plus 15. And then we need to set our first derivative just now with 0 to find the stationary points. So negative 3 over 2x plus 5 plus 15 equals to 0. And then we will get x equals to 10. So x equals to 10 is the candidate for our maximum profit. Step 3. Confirm it's a maximum. We use the second derivative test. So we differentiate again and we will get negative 3 over 2. Since negative 3 over 2 is a constant negative number, so which means negative second derivative means that the graph of px is concave downwards. So the stationary point at x equals to 10 is a local maximum. So profit is maximized at x equals to 10 radio sets per day. Step 4. Compute the numerical revenue, cost and profit at x equals to 10. Cost at x equals to 10, so we need to put x as 10. So we put C 10 equals to 1 over 4 10 square plus 35 10 times 10 plus 25, and we will get 400. So the revenue x equals to 10, we will get 450, and the profit x equals to 10, we will get 50. We will use both ways and we will still get 50. So part B. Show average cost per set is a relative minimum at x equals to 10. Average cost per unit, is defined by AC, which is the average cost, equals to the cost minus per set. So cost per unit, 1 over 4x squared plus 35x plus 25 divide by x, and we will get 1 over 4x plus 35 plus 25x. And then we differentiate ACX to find stationary points, and then we will get 1 over 4 minus 25 per x squared, and then set the differentiate just now equals to 0, and then we will get x equals to plus minus 10, but we will need to take the positive number because x equals to more than 0 production, because we can't find a negative production. So we will take x equals to 10, that is a critical point of AC prime x. So the second derivative of ACX is to classify AC double prime x, which is 50 over x cubed. So we evaluate at x equals to 10, and then we get AC double prime 10 equals to 0.05, and it's a constant positive number. So positive second derivative means ACX is the graph is concave upwards at x equals to 10. X equals to 10 is a local minimum at the average cost, so the cost per set is a relative minimum at x equals to 10. Numerical average cost at x equals to 10, we will get 40. So the average cost per set at that output is 40 ringgit per set. So our final answer is, for question A, x equals to 0 radio sets per day gives maximum profit. The maximum profit value is 50 ringgit per day. And for B, the average cost per set is 1 over 4x plus 35 plus 25 per x, has a stationary point at x equals to 10. Since AC times 10 is more than 0, the point is a relative minimum. Numeric average cost at x equals to 10 is 40 ringgit per set.
So now we're moving to the question number 4. Question number 4 asks us to evaluate each of the following limits using L'Hopital. For the number 1, limit x approaching to 0 sine 3x over 4x. First of all, we have to check the limit, whether the limit is applicable to use the L'Hopital rule or not. Just substitute the 0 into sine 3x over 4x. Then we got 0 over 0, which is indeterminate form. So now we are capable to use the L'Hopital rule. To use the L'Hopital rule, we have to differentiate numerator and denominator. Differentiate sine 3x, we got 3 cos 3x, while differentiate the 4x, we got 4 cos 3, and then we substitute the 0 into the limit into the question. We got cos 3 multiplied by 0, 1. So the final answer will be 3 over 4. For For the question number 2, limit n approaching to infinity 3 exponent 2n over 4n square. Same with the first question, we have to check whether it is applicable to use the L'Hopital or not. First, I substitute a very large value of n. When n goes to infinity, the numerator becomes infinity and the denominator also becomes infinity. Infinity over infinity, we got indeterminate form. Next, we differentiate numerator and also denominator. So differentiate 3 exponent 2n, we got 3 exponent 2n multiplied by 2. Then differentiate 4n square, we got 8n. So 3 exponent 2n multiplied by 2, we got 6 exponent 2n over 8n. Okay, when n goes to infinity, the numerator is still infinity and the denominator is still infinity too. So we apply the L'Hopital rule one more time. So now limits n approaching to infinity 6e2n over 8n. We differentiate the numerator and also denominator. Differentiate 6e2n, we got 6e2n multiplied by 2, and differentiate 8n, we got 8. And then 6 exponent 2n multiplied by 2, we got 12 exponent 2n. As n approaches to infinity, and also as n approaches to infinity, and the denominator is a constant, infinity divided by constant still got infinity. So that will be the final answer.
In this video, I will explain how to evaluate limits using L'Hopital's rule. I will explain every step clearly, including how the limit behaves as the variable approach a certain value. For question for Roman 3, we are asked to find the limit as x approaches 0 from the positive side of x squared times ln x. To apply L'Hopital's rule, the expression must be written in the form of a fraction. So, x squared times ln x is rewritten as ln x divided by 1 over x squared. As x approaches 0 from the positive side, ln x approach negative infinity and 1 over x squared approach positive infinity. Hence, the limit is now in the indeterminate form of negative infinity over infinity, which allows us to apply L'Hopital's rules. By L'Hopital's rule, we differentiate the numerator and denominator. The derivative of ln x with respect to x is 1 over x. The derivative of 1 over x squared with respect to x is negative 2 over x cubed. After differentiate, the limit becomes the limit as x approaches 0 from the positive side of 1 over x divided by negative 2 over x cubed. This expression can be simplified. After simplification, the expression becomes x squared divided by negative 2. As x approaches 0 from the positive side, x squared approaches 0. Therefore, the final value of the limit is 0. Next, for question for Roman 4, we are asked to find the limit as n approaches infinity of n times e to the power of 2n. As n approaches infinity, n increases without bound, and e to the power of 2n also increases without bound. Therefore, the product of these two terms results in infinity times infinity. Since this limit is not in an indeterminate form, such as 0 over 0 or infinity over infinity, L'Hopital's rules cannot be applied. So, the answer is infinity. Thank you for watching.